So let's take a look at this fracture. So I'm going to come here and drop a for each loop. We'll do for each named primitive. Okay, plug that in. So this got an error because it's looking for that name attribute. If we change this to that class attribute that we just made, that should work. And then reset cached pass, and then we've got one piece. Let me. I'm going to go. If we go here to single pass, that will just kind of just show you one piece at a time. So the next piece, next piece. I want to get to one of these big flat pieces. If we just kind of keep skipping forward, there we go. So I just want to grab one of these, as I think that's the most important, piece of the fracture. Is going to be the most noticeable, right? So back to the start. So what we're going to do is scatter some points on this and run a boolean fracture on this. Okay. So first we need to scatter some points. And what we'll do is use the density. So we'll turn off the force total count and use the density scale. So I'm going to drop this down to 0.01. So we literally just get a few points there. And let me just, so, this will put a sphere here onto the, let me just show you that. So if we copy spheres onto this, we've got points along the edge, but mostly in the middle, but we don't have points out here, which means you kind of get a pattern like more fractures in the middle than around the border. So I'm just going to simply scale it up, each piece a little bit by just 0.2. 1.2, something like that. Okay, so that means if I copy sphere onto here, it's going to be fracturing this part here. And to make sure that this is not scaling from the center, you can see it's going up a bit there. Just go into pivot transform and set this to $CX, $CY, $CEZ, and that will grab the center of the piece. Okay, perfect. And then we scatter those points. And then we're going to be copying spheres onto that. So copy to points, our old friend. Do that into the right, and then spheres into the left. There we go. So we'll want the spheres as polygons, and we'll just give it a bit of subdivision for now. What we'll do is add more subdivision later on. We'll subdivide it or remesh it, I think is what we'll do. Let me just turn that off. We don't need it. There we go. So yeah, we need to obviously affect the scale here. So attribute randomize for the scale. And we'll set this to, we do want it on the point, and we want this to be p-scale. Okay, and obviously we need bigger pieces than that, so let's do 10 and 20. And it's just a one dimension, so just a float value. So they're all overlapping there, but that's perfect. Okay, that's what I want. It doesn't matter. Well, it'll give us more interesting results, right? So we'll set our first mountain down and give ourselves some big features first of all. 10 and 10. Maybe drop the roughness down. Okay, so we just get these kind of big lumps. And then I'm going to remesh this. So, when we're doing this randomizing the scale, you can see we get different levels. We've got big polygons there and a bit smaller there. Not a massive difference, but it's good. What I like to do is remesh this so it's all the same, basically. And so that means the resolution of our fracture is uniform. So drop down the remesh. Let me just escape and set this. Yeah, you can see that's too small at the moment. I'm going to set this to 1. So that should be okay. Okay. And then drop another mountain, and I can do some smaller detail now that we've got a bit more resolution. I'm just going to leave that at default. Okay, and then drop our boolean fracture. So our geometry into the left and this into the right. And then we'll call this concrete. Will be the name that we give it, okay? And then if we turn the visualizer off for that and visualize the name attributes. It's not working because we need to convert it. So yeah, this, you know, I got rid of that. You can see it's a poly soup there once you unpack it. So just drop a convert for each loop. You can see that's running the fracture now. And hopefully we should see a fracture now. And maybe we need to reset this. There we go. So these are our concrete pieces. As you can see there's still maybe a bit more concentrated in the middle, but that's okay. Let me see if I get rid of that, see if we can see the difference. Yeah, you can see it more now. We got definitely more detail in the middle. You can see where the spheres are all kind of overlapping in the middle, and then on the outside we get these big pieces. So that, yeah, that's why I had that transform there. Now, since we've got you know, this piece is almost kind of duplicated going up the tower. That means the scatter will be quite similar. The result will be pretty similar, you know, going up. And we, you know, we'll get the same pieces going up, and we don't want that. So what we need to do is change the global seed here. We need a value to change that. And a way to do that with a for each loop. The problem is with for each loop is that once you got, you know, each piece coming through, if you look at the, you've got this class value. I don't know why, for some reason that's not working for me using that. You know, you'd think to be able to just drop that class in there or here, but it doesn't work for some reason. So what I do is come here to the for each begin, create a meta import node. Okay, and what that does is give you this other node that basically you use to reference information which pertains to the loop. So, you know, what's going on in the loop. So all this does, if you go into the detail of this node, you'll see we have iterations. So where it gives you the information of what current iteration you're on. So here you can see single pass there says 26. So we won't, the way to get access to this number as the loop is going around in terms of code is with this meta import node. We got enumeration there, which is, I think, how many pieces in total, and then the value is basically the same really. So we want access to that here because that will change the seed per piece, right? Essentially. So in here we need a little expression. So we're looking for a detail attribute. Okay. And we need to go ahead and find that node. So we need to go .. to go out, and then you can see we can start getting some suggestions. So we want the for each begin metadata, metadata, however you want to say it, and then another. Oops, what am I doing? That's weird. Delete that. Okay, I think you can leave it, doesn't matter really. Comma, and then we need the attribute, the name of the attribute that we're looking for is value. Okay, I think you could use that iteration as well. And then 0, we're not doing anything different with that. I think that's the primitive. No, I'm not sure, but you need a 0 at the end anyway. So if we press that now, you see we get that 26 in there, and basically that changes the scatter per frame. Okay. So that's basically it. If we plug this into the bottom and then visualize, let that run through. Actually, press escape, go here and turn off this single pass that will run through all of the pieces. So you can see that running through there. Okay, got our fracture there. So you can see now each piece, you know, each level is different. We don't have repeating pieces, repeating kind of shapes. So quickly, I'm going to merge these together. All right. Don't worry, I know we'll have the repeating name attribute from here, but we'll just assemble that again later. And I'm going to merge those pieces in together and file cache this. Okay, so save current frame into geo is fine, and we'll call it, let's call it concrete frac .bgeo, and then save that to disk, load from disk, because that that whole for each loop takes a bit of time, right? Okay, and then just it's good practice just to drop an exploded view on this, just to see what's going on. Okay, just get a sense of your pieces. You could run another boolean fracture on that again. These pieces aren't being spread because they haven't got a name attribute, so but that's fine. Okay, great, looks nice.